Hello everyone. Today's topic is the cosine law for obtuse triangle trigonometry. Really there's nothing new in this lesson, just showing you that the cosine law operates the exact same whether you have an obtuse triangle or an acute triangle. Here's a quick reminder of the formula. I've written it in the side length form and the angle form. Truly, this is the one you need to know. The angle form is just an extra thing. If you feel like remembering it, you can, but you don't need it. The side length's all you need, or this true form is all you need. You can rearrange it for the angle A, B, and C, and that is what I've done when I've put them into these other forms. So this is the one we really want. This one over here is optional. If you feel like memorizing it, go for it, but I truly wouldn't memorize it. I would know how to rearrange my formula if I really want to use it, but you don't need them at all. The side length formula works for both angle and side length, and I'll show you that in the video, so we shouldn't have to worry about that. All right, let's look at example 1. I have a triangle here. Remember from your acute triangle work, I like to write out my little list. That way, it'll tell me, am I using cosine law or sine law? I don't have to worry about remembering if it's angle, side, angle. Is it side, side, side? All those sorts of things. Now, if you do know those details, that's great too. I'm just saying this is something else you can do. So angle B is 15 degrees. Side C is 14 degrees. And then, side A is, I said degrees, just 14, and I don't have a unit, so you can just put U's if you really want for units, and then afterwards the person could have said, oh, that's centimeters, and then you can adjust your answer. That's 12 centimeters instead of units, and that's 14 centimeters instead of units. Anyway, if I look at my menu there or my list, I don't have a completed row, so that means cosine law. So let's get doing this. So I'm looking for this side B, so I have to choose a correct arrangement for the cosine law, and here it is. Write it out, and again we just go through just like we did before. Write the things in, calculate the numbers. Cosine law, pretty straightforward. Okay. 12 squared, 144. 14 squared, 196. The first part, the negative 2 times 12 times 14 will be 336. And then I'll times that by cos 15. Remember, the biggest mistake people make is I've got to make sure I multiply these two numbers together before I worry about adding them to the 144 and the 196. All right, 144 and 196 will give you 340. And then once I calculate what I've put in that red box, you'll get negative 324.6, which works out to 15.4. And again, I should be writing b squared the whole time here. I've gotten lazy. I'll just start that there. I want b, not b squared, so I have to take the square root. So b is then going to be equal to 3.9. And there we go. We found that side length. The exact same work as we did in the previous chapter. Another example. Make my list, A, B, C. And after you've done these lists for a while, you'll already start to know. You'll pick up on the side, angle, side, and all that sort of thing. Angle C is what I'm looking for. And I have all the sides. Quick reminder, if this is angle A, then this ends up being side A, the opposite. So that is the 20.3. If this is angle C, then this has to be side C, 33.5. This is angle B, so this ends up being side B, that's 17. Okay, now as you can see, we have that angle C. I could use my rearranged formula if I wish. I'm not going to. Again, it's totally optional. And I feel if I show you the optional way, you're going to think it's mandatory. So I'm going to show you just using the basic cosine law. So I have to start off with using the proper form. I want something with angle C in it. So that means I'll have to start off with c squared. And then it just takes a second to write the rest out. Hopefully you have that memorized still. And if you don't worry about it. It'll come back to you. Okay, but now this time I know c squared. So c squared ends up being 33.5 squared. A squared is 20.3 squared. B squared is 17 squared, I guess. Minus 2 times 20.3 times 17 times cos c. All right, number crunching time. Get your calculator out. So 33.5 squared is going to be this amount. By the way, as I'm writing this out, when you're doing these, make sure, like, attempt this yourself. So why not pause it now, finish it off, and then compare. All right, getting back to it. 20.3, 412.09. I'm taking everything to 2 decimal places. 17 squared is 289. And yes, I've pre-calculated all this. I'm writing this out from a sheet of paper. I don't have this all memorized. Again, we've got to put these things together, right? Or as much as we can. We don't know what the side or angle C is, so I can't go all the way. But I end up getting negative 690.2 times my cos C. So meaning 2 times 20.3 times 17, I'm sorry, is a 690.2. All right, so now I'm going to start gathering my like terms, but again, you've got to keep these guys together. Order of operations, it's a multiplication, so I have to multiply before I can worry about adding and subtracting them. Okay, so on the left side, that value does not change, it stays the same. When I add my 2, my 400, my 200, I get 701.09, and then minus my 690.2 times cos C. That doesn't change because I haven't done anything to it. Now it's just basic equation rules. So you want to move everything away from what you're wanting to know. I want to know the cos C. So I want to know this part. So you move what's not attached, is what I always tell people. Move what's not attached first, which would be the 701. And you move something to the opposite side by performing the opposite operation. So I'm going to subtract that over. That's gone. What would I get? I get 421.16. And that is equal to my negative 690.2 times my cos C. Okay, now I move what is attached. So the 690.2 is attached to the cos C. It's attached through multiplication. So to move it across, I have to divide. Negative 690.2. What I do to one side, I must do to the other side. Okay, that'll be gone. I'm going to write the cos C first this time. I'm just going to kind of flip my equation around. You always want your unknown on the left at some point, and you can flip-flop your left and right as long as you maintain the values. All right, so the 421.16 divided by 690.2 ends up working to be roughly here. I have negative 0.6101. And then I don't want cos C, I want angle C. So I go angle C is equal to inverse cos negative 0.6101. So we're used to, or your calculator's kind of programmed to, if you give it the value, it'll find the angle size. In this one, we have the value already, or I'm sorry, the calculator it's used to, you put in the angle size, like 100, and it's going to spit out a value. We're the opposite right here. So that's why we're doing the inverse of cosine here. We have the value, we're searching for what size of angle must go along with it. So once I type that into my calculator, I'd get 127.6 degrees. And now how you put that into your calculator does vary depending on your calculator, but there's two main ways. If on your screen the words cos and sine will pop up and appear, then you will go second function cos and then type in negative 0.6101. If when you hit sine and cos and tan, it basically blinks at you, the calculator, it does not show those words, then you type in your value first, negative 0.6101, then second function, then cosine. That should get you your answer. All right, we'll do one last example. This, as you can see, it's a continuation of the previous example. We solved for this last time. So now what we're wondering about is the A and the B. We could use cosine law here. Or sorry, we could use sine law because now I've created an angle side pair. But let's look for angle A and angle B using the cosine law. So again, if I'm going to look for angle A first, I have to use the form of the cosine law with angle A in it. So that's going to be the A squared version. And again, I'm using the traditional version of it. I'm not using the reworked version. That is totally fine if you use it. You're allowed to use what I showed you on that one of those opening slides. I'm not doing it because really it's more to remember, and you don't need them. Just by doing what I've done in that example 2, you're going to get the right answer, so you don't need those additional formulas, but they are a little bit quicker if you feel like putting the work in to either memorize them or learn how to rearrange these equations, how to get to them. You can do it, but I'm kind of saying to you, I don't know if it's worth the time. Okay, so side A, again, side A, that's going to be opposite, so that's going to be 20.3 squared. The B is opposite side, or angle B, so that's going to be 17 squared. The C, it's going to be 33.5 squared. Minus 2 times the B value times the C value times cos of A. All right, and once again, we'll start calculating our numbers. So some of these we've seen before. I'll talk less and write more here. They're in a little bit of a different order. You can see the 1,122 was on the left side before. And then again, reminder, I have to calculate these things together. I only know this much though, so I can only do that part right now. And that ends up being 1,139 times cos A. And then now I start my process of collecting the like terms and then moving things around. So I'm going to collect these two first, so 412.09. Once I add those two things up, I get 1,411.25. Again, reminder, I'm not a robot. I have this written out. Minus 1,139 times cos A. I don't want to make you guys wait while I do my calculations. These videos are long enough already. So now I'll start again. I want to get this thing by itself, so I have to move things to the opposite side. You first of all move what is not attached, and you move it to the opposite side by performing the opposite operation. So I subtract this from here. Oops, 11.25. That's gone now. What did I get for a value there? I got negative 999.16. Remember, feel free to pause the video at any time and try it yourself and then compare it to what I get. Equals negative 1,139 times cos A. And then now I move what's attached, and I move it through division because attached, really that's multiplication. What do I get when I get those? Okay, so now again, I'm going to move my cos A over here now that's by itself. When I do that division, I get positive, so 0.8772. All right, and then from that first, in our first video, we learned about how the acute angles of a cosine, from cosine, will always be positive, and the obtuse angles will always be negative. So right now, I already know I'm going to have an acute angle. Truly, though, that doesn't really tell me too much. I got to keep going, but I kind of, that's just something I know as I'm working through. I'm looking for angle A, so I'm going to take the inverse cos of this value, meaning I know the value I'm looking for. What size of angle corresponds to that? Your calculator is going to tell you it's 28.7 degrees. All right, so there's another example of how to find that angle. That was angle A we were looking for without using that special formula, just using the traditional formula. If I wanted to find now angle B, you could do the whole thing over again, or you could use your triangle properties where you know all three angles add to 180. So 180 minus the things you know. So the 127.6 minus my 28.7, that would equal 23.7. All right. So Again, cosine law doesn't change from obtuse triangles to acute triangles. Sine law will, but cosine, everything's the same, so that's nice. All right, have a good night, everyone.